Okay, so Earth rotates once in 23 hours and 56 minutes. Earth rotates once in how much time?
I don't know, 24 hours. Who I'm talking to, because you'll do some crap like this. You would think it was 24 hours.
That's exactly what I did. Okay, so Earth rotates once in 23 hours and 56 minutes.
That's, believe it or not, though, that's a big difference from 24 hours.
Okay, so now, how come our watches don't go 23 hours, 56 minutes? Because we don't care how long it takes Earth to rotate. We care how long it takes the sun to return to its position, and that's 24 hours. So where the extra 4 minutes go, I'm going to tell you. In the day that it took to rotate, 23 hours, 56 minutes it took to rotate, Earth moved in its orbit. If you get enough uranium in one place at the same time and start the reaction, you light the fuse. If you want to make a bomb, you want to isolate the uranium-235 from the uranium-234 and 238. About no more than 1% of the uranium that is mined is uranium-235. So you want to enrich that. You want just the uranium-235. Well, how are you going to do it? These atoms are mixed together completely. How are you going to pull out the one that's in between the other two? Use a centrifuge. Well, centrifuges don't work on solid matter. You have to turn the matter into a fluid.
Do you have a favorite planet, star, or galaxy out there?
Favorite planet? Well, it's a cliche, right? But I actually asked, this is a name drop now, I asked Jeff Bezos that question once, and so there's a name drop. And he said, correctly, Earth. Right? Earth is the best planet. And that's true. So because of everything I've just said, right? I just said it's the only place where meaning exists potentially in a galaxy of 400 billion suns. So that would be your favourite planet as a result of that. We have evidence there was life 3.8 billion years ago, something like that. And the Earth's 4.5 billion years old. So pretty quick in geological time you get life. So that means that on this planet, it took over 3 billion years to go from single cell life to anything more complex than a single cell. If you say that's an unbroken chain of life on a little piece of rock in a violent universe, and that chain was not cut for 4 billion years in order to get us. And that might be a big ask, right? We live in a really violent universe. You look at the Milky Way and you look at that arc of stars across the sky, 400 billion suns. All there will be up there at best is slime. It's just slime. Nothing. Right? And I think that's a reasonable guess.
What'd you do? Did you take over the plane, move it with your spaceship? Or why'd you put them over the ocean? So if you crashed, you wouldn't kill anybody?
Right.
Why'd you do that? Like, what is all this?
And what's the thing with the gas being gone?
Right. Because I guess they like picked it up and took it.
Huh.
I don't know. We are watching you. What else does it say? Definite surprise. Issued a certificate stating he was in perfect health and had not consumed any drugs.
One of the greatest works of science ever is Principia Mathematica. In there, Newton unleashes the 3 laws of motion, the laws of gravity. He figures out how the solar system works. He's figuring out, how do these planets sustain their orbits? Are they pulling on each other, and in what way and how? He figures all this out. But wait a minute, every time Earth goes around the backside between the sun and Jupiter, Jupiter's going to tug on it a little bit. Comes back around again, Jupiter tugs on it again. Jupiter has a strong gravity. What's going to ultimately happen to Earth's orbit? There's a 10-minute movie called Powers of 10. It was made in the 1970s, 78. And it starts with a man laying down at a picnic in a park outside of Chicago. And we start with a scene 1 meter wide and 1 meter tall of a man and every 10 seconds we're going to go 10 times farther away. And we do that.
With the
and you
camera.
see how many jumps. And it's an early CGI, but it wasn't even use computers. It was very well done in its day.
10 times farther away.
Every 10 seconds. And you go to the edge of the universe. They said now, then we zoom back and it says now we're going to go 10 times closer every 10 seconds. And so you go 10 times closer. And in keeping with astronomical extrapolations, many of us said, me included, if we have a supermassive black hole in these 3 galaxies, and these are the first 3 galaxies we've even looked for them, then clearly every galaxy has a supermassive black hole. Why not presume that and then go check? And that's what we did. Bring in the Hubble telescope, which had very good vision down into the centers of galaxies. Sure enough, every galaxy we have ever observed in its center has a supermassive black hole. How about Andromeda? Andromeda's almost our twin. It's another grand spiral galaxy, and it's the closest big galaxy to the Milky Way. It's a little bigger than us, but does it have a supermassive black hole? It sure does. So they said we want everybody's high noon to have the sun at the top at how high up it gets.
Right.
Everybody should have a chance at a high noon.
Right.
So you carve up the world like orange slices.
Like orange slices.
Okay.
Right.
We are binning the time you would experience into zones. So 24 zones. We just said an hour is good enough.
Okay.
Okay?
Right.
Hour is fine. But we could have binned it into 30-minute increments.
Could have.
Time zones.
Right.
Could have, but we didn't.
Could have made it into 1 minute increments.
Into 1 minute increment.
And then you walk over to the other side of the room, you're like, oh man, I'm in a different time zone.
Right. And you have to change your time by a minute. By a minute. Okay?
The question was, the central question that was immediately raised by those calculations is this. What happened to all the stuff that fell in? The way I've described it, the way Einstein's theory describes it, is somehow that stuff goes to the singularity, whatever that thing is, the end of time, the region of space-time that's so convoluted and distorted that we don't understand how to describe it at all. But then, one day, the whole thing is gone. All that's left in the far, far future is Hawking radiation. Those particles that were produced in the vicinity of the event.
Okay, so now, how come our watches don't go 23 hours, 56 minutes?
Right.
Because we don't care how long it takes Earth to rotate. We care how long it takes the sun to return to its position in the sky.
That's right, because we're talking about the meridians.
Yes. How long does it take the sun to get back to the meridian? That's 24 hours.
Gotcha.
So where the extra 4 minutes go?
I don't know.
I'm going to tell you.
Okay.
In the day that it took to rotate, the 23 hours, 56 minutes it took to rotate, Earth moved in its orbit.
Yes. Right, because we're also not just rotating, we're going around the sun itself.
So we go 1 day's worth of our orbit around, and the sun is not lined up where it used to. We have to turn a little extra to line the sun back up.
Gotcha.
Every one of these days, we have a little extra turn.
Right.
Okay?
Right.
To line the sun back up.
Okay.
That turn is 4 minutes. Is it aliens? That could be. Like I said, it's not my first thought. I promise you, it will be my last thought. But it's not in the list. It's in the list. It's just way down based on the history of trying to understand things that we don't understand. We have 2 more objects that have come through, and they have some weird properties. The brightness, the rotation rate, and so they don't match some of our models for what comets and asteroids should do. Whatever anomalous behavior these objects exhibit, I'm delighted that they're finally in the catalog, and we'll figure it out one day, maybe. The estimate for the chances of it hitting us are down at this moment, between 1% and 2% at the time of this recording. Now, what does that mean? I'll tell you. It means that the orbital trajectory we have for it, when projected forward in time, has an uncertainty cone where the asteroid could end up anywhere in that cone, but more likely in the center of the cone. If it stayed in the center, you can ask, how close to Earth would it come? About the distance from Earth to the moon. Anyhow, there's an asteroid recently discovered, 2024 YR4. That's its designation. And you know that was discovered late in the year 2024 because the letters are late in the alphabet. In fact, I think it actually puts us in December for 2024. The size of the asteroid is still uncertain, but we know it's somewhere between 50 and 100 meters. Some of that uncertainty will be overcome by tasking the James Webb Space Telescope.
Let's say you burn a book. We're very fashionable in today's current political climate. So burn a book and collect everything that comes out of the book, all the ashes and all the gas and everything. Then in principle, you can reconstruct the book. Not in practice, right? But you can imagine if you collect every single thing and measure it, in principle, you can reconstruct the book. Information is conserved in all of physics, which means that, so basically, if you can measure everything perfectly, you can predict what happened in the past and what's going to happen in the future. It's called determinism, that, right?
You know what's happening around then? China says they want to put taikonauts on the moon. Everything China has said they want to do in space, they have done in space. Let's rewind for a moment. Back when we stopped going to the moon, we wanted to do something interesting in space. We said, let's have a space station. Originally, it was Space Station Freedom. Then the Soviet Union collapses. There are Russian scientists. We don't want them going to whoever might be the new enemy. We want to make friends with them. So we turned the Space Station Freedom into the International Space Station, and the principal international partners is the United States and Russia, and Europe joins in and other countries as well. But that means they are our friends post-Cold War era.